Right now, we will look at simplifying radicals that are other roots besides square roots. When we were simplifying square roots, we're looking to pull out any factors that are perfect squares, or if we have x's with higher exponents, we're looking for those exponents every factor of 2, or even exponents to be able to simplify and pull those out of the radical. Now in this case, we're looking at cubed into the 4th, and we'll do 1 to the 5th. So first thing, I'm going to make a little chart over to the side to look for what are our perfect cubes. And maybe we'll go back and we'll do a couple to the 4th and to the 5th. So, I'm going to skip 1 because we don't need to pull out factors of 1. And this will be good for now. So 2 cubed is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216, and I think we're good. We'll go back to 4th when we do one of those. So let's start with the cube root of 40. So I'm looking for a perfect cube. So a number that goes into 40 that we can take the cube root of and it will come out nicely. So 40 is the same as 8 times 5, and I'm picking 8 because 8 is on my list of numbers cubed. So since 8 is 2 to the 3rd power, when I do the cube root of 2 to the 3rd power, that's going to simplify just to 2. So it's like this 2 comes out of the radical, and then I have to leave the cube root of 5 as it is. The 5, I cannot simplify that. So this will be 2 cube root 5. How about, let's do one with x's, the cube root of x to the 13th. So the cube root of x to the 13th, I'm looking now for an exponent that is a multiple of 3 to be able to simplify. So if I think about numbers that are less than 13, the number less, because 3 doesn't go into 13, but if I go down to 12, so let's break this down to x to the 12th times x. Now the cube root of x to the 12th is going to be x to the 4th. So if I want to rewrite this as a rational exponent, or just think about it as 12 divided by 3, that'll simplify to x to the 4th on the outside of the cube root. So I'm left with x to the 4th, cube root of x, because that x needs to stay inside. I'm going to do another one with an x. Cube root of x to the 17th. Now I'm always breaking it down, so I can't go up to 18 if you're thinking, oh, 18, 3 goes into 18, that doesn't work. We can't just multiply an x in, we have to break it down. So if I go down to 16, 3 does not go into 16, 15 will work. I can do 15 divided by 3 and have some of these x's come out. Now if I break this down to x to the 15th, I'm left with x squared, because 15 plus 2 is 17. So now I'm going to look at this as 15 divided by 3, so that's going to come out as x to the 5th. So x to the 5th, cube root of x squared has to stay inside. Okay. Let's do one more cube root, and then we'll do a 4th root. Let's do one where we have a couple of different things. How about 54? Switch to a and b. A to the 9th, b to the 4th. So I have a couple things I need to break down here. So I'm looking at 54, And thinking about my list of perfect cubes, the only things that could work would be 8 or 27. 8 does not go into 54, but 27 times 2 is 54. So I'll break that down. 8 to the 9th, that actually is good because 3 goes into 9, so I'm not going to break that down at all. But b to the 4th, that 4 is not a multiple of 3, so I'm going to go down to b to the 3rd, and then I still have a b left over. So now if I look at what can come out, 27 can come out as 3, because the cube root of 27 is 3. A to the 9th can come out as 9 divided by 3 is a cubed. B to the 3rd, 3 divided by 3 is 1, so just b. And that looks like the 2 and the last b need to be left out, or sorry, left in. So 3a cubed b come out, cube root of 2 and b stay in. So now a 4th root. So now a 4th root. The 4th root of 162 x to the 10th. So if I'm looking at a 4th root, I want to break this down to numbers that are perfect fourths. So some number to the 4th power. So 2 to the 4th power is 16. 3 to the 4th power is 81. 4 to the 4th power is 256. And you can keep going. 625 is the next one. But usually it's going to be one of these numbers. So in this case, the 162, that will break down to, looks like 81 times 2 is 162. Now for my x part, I want this exponent to be a multiple of 4 now, so that I can take that exponent divided by 4 and have it come out evenly or nicely. So starting with 10 going down to 9, 4 doesn't go into 9, but it does go into 8. And I'm left with x squared. So the 4th root of 81 is 3. I'm going to leave that 2 inside. The 4th root of 8 to the 8th will be 8x squared. Sorry, x to the 8th. Because I would be doing 8 divided by 4, and then this x squared stays in. So the 3 and the x squared came out, and I'm left with 4th root of 2x squared stays in the radical. And last, let's do a 5th root. The 5th root of 96x to the 18th. So I'm thinking this isn't that big of a number. 2 to the 5th power is 32. And again, you can kind of keep filling those numbers in to see other ones you might come across. But this one looks like it's going to break down to 32 times something. 32 times 3 is 96. And now since we're doing the 5th root, 18 needs to be a multiple of 5. So going down, 17 doesn't work, 16 doesn't work, 15 is a multiple of 5. And then I'd be left with 15 plus 3 is 18. So 5th root of 32 is 2. 3 cannot come out. 5th root of x to the 15th is x to the 3rd. 15 divided by 3. Or sorry, 15 divided by 5 is x to the 3rd, and then this x to the 3rd needs to stay in. So my answer would be 2x to the 3rd, 5th root 3x to the third.